Hey, fourth graders, it's Mrs. Seals back for our next science lab. So hopefully you remember that for the last couple weeks, we've been talking about energy. We have talked about mechanical energy. We've talked about sound energy. Today, we're going to talk about another form of energy called electrical energy. And your target says I can differentiate between conductors and insulators of electrical energy. So to review, hopefully you remember that energy is the ability to cause change or do work. And I gave you a word or an acronym to remember the 5 forms of energy that we're going to be learning about in 4th grade. Hopefully you remember that is the word melts, where each of those letters in the word melts is the beginning letter of another form of energy. So the M stands for mechanical, which was the first form that we talked about. Hopefully you remember that mechanical energy is the energy of movement or motion. E stands for electrical, which is what we're talking about today. The L stands for light. The T stands for thermal, which is another word for heat. And the S stands for sound, which we talked about last week. So, what is electrical energy? Electrical energy is a form of energy produced when electric charges flow through a conductor. Electric current travels in a closed path, creating an electrical circuit. When the circuit is closed, the electrical current can flow. Sometimes you might hear this called a closed circuit. Other times you might hear it called a complete circuit, but that's the same thing. So when we look here in this diagram, this is a closed or a complete circuit because the power is able to flow out of the battery through the wire, which is a conductor, to the light bulb, and then from the light bulb back to the battery. And since the electricity is able to continuously flow, that's what keeps the light bulb on. And that's, again, called a closed circuit or a complete circuit. When the circuit is open, the electrical current cannot flow. This can be called an open circuit or an incomplete circuit. So if you look at this diagram, we have energy that's able to flow from the battery to the light bulb through this conductor. But then look, after the light bulb, we have this space where maybe the conductor has been cut, maybe it has been broken. Not sure what happened, but the electricity is not able to jump from here to here. It has to be a closed or a continuous path. So because this circuit is open or incomplete, the light bulb is not on. We have no way for the energy to get back to the battery to complete that circuit. So let's talk about this word conductivity. Conductivity is the ability to conduct energy, in this case, electricity or electrical energy. To conduct means to allow energy to pass through it. So a conductor is a substance or object that allows the flow of energy. Today we're talking about electrical conductors. So these are materials or objects that allow electricity to flow through them. So some examples of conductors are silver, gold, copper, steel, and this says seawater, but any kind of water is also an electrical conductor. That's why you always hear from your parents or grown-ups that electricity and water do not mix. It can be extremely dangerous. So this shows us 4 types of metals, but all metals are good electrical conductors. Inside of the wires usually is copper because copper is the best electrical conductor, but sometimes they'll be made with other metals as well because copper is kind of expensive. All right, so an insulator is the opposite. An insulator is a substance that stops or slows the flow of energy. So electricity is not able to get through it. So examples of insulators are rubber, glass, oil, diamond, or dry wood. Plastic is also another really good insulator. That is why our wires are usually coated in plastic. That's to keep you from feeling an electric shock. If these were not coated in plastic and we just had the exposed metal, probably copper wire underneath here, whenever we hooked this up and had a closed or a complete circuit, we would feel an electric shock. So the plastic is here because it's a good insulator and it protects us from the electricity going through the conductor, okay? So today what we're going to be doing is we are going to be investigating some objects and trying to determine which ones are conductors and which ones are insulators, or in other words, which ones allow electricity to flow through them and which ones stop the flow of electricity. So in order to do this, first you're going to be building a simple circuit. So let me show you how to do this. So all circuits have to have a power source or a source of energy. Okay, in this case, we're using a battery. So this battery is in a battery holder. When I take it out, I have the positive end of the battery, the negative end of the battery. But we're going to just keep it in this battery holder. Okay, so that's my power source. And then I have a light bulb. This could be called a load. This could be called an output. It doesn't have to be a light bulb. It could be a buzzer. It could be a fan. It could be anything that requires electricity. Okay. In this case, we're using a light bulb. So I need to get my electricity from my battery to my light bulb. So what I'm going to do is I'm going to use these wires. Like I just told you, oh goodness. Inside of these wires is some sort of material that's a really good conductor, probably copper, maybe something else, because it's going to allow the electricity to flow from the battery to the light bulb and from the light bulb back to the battery. Okay, so I'm going to connect my wires, making sure I have metal touching metal because metal is a conductor. If I had this clipped onto the plastic, it would not work because plastic is an insulator. It would stop the flow of electricity. So I'm connecting my light bulb to my battery. All right, and I don't know if you can see that at home, but the light bulb has turned on. So that means I have what's called a complete circuit or a closed circuit. So remember, that means that my energy is able to flow from the battery through the conductor to the light bulb, back through the conductor to the battery, and it continuously flows. That's what we call a complete or a closed circuit. We have a continuous flow of energy. If I disconnect this in any place, my light bulb goes off because now I have what's called an open or an incomplete circuit. I have no way for the electricity. It can get from the battery through the conductor to the light bulb, but once it gets here, it can't just jump. I need a continuous path. So my light bulb is off because I don't have a way for the power to get back to the battery and form that continuous complete circuit. So this is what we call an incomplete or an open circuit. Okay? So in order to investigate which objects are conductors and which objects are insulators, I'm going to take the object. So the first object we're going to test out is this. It's called a washer. It's made of metal. It's not like a washing machine. It's you use it with like nuts and bolts and screws, maybe to hang stuff on your wall or to tighten things. Okay, it is made out of metal. So I want to find out if this is a conductor or an insulator. So what I'm going to do is I'm going to connect my object to my wire, and then I'm going to touch the object to the metal part on the light bulb. The light bulb lights up. So what that tells me is that this object is a conductor because the energy is able to flow from the battery through the conductor to the light bulb, and then look, it's able to pass through the washer, through this conductor and back to the battery, and it has a continuous flow. So it's a complete circuit or a closed circuit. This is allowing the energy to flow through it, which is what a conductor is. So this object is a conductor, all right? If I did all this and the light bulb did not turn on, that would mean that this would be an insulator because it would be stopping or slowing the flow of electricity. But since it's turning the light bulb on, that tells me electricity is able to flow through it, so it's a conductor. So we're going to test out some more objects today. Before I test them out, I'm going to have you make a prediction about each one. So think about the things you saw in my PowerPoint. Think about things we've talked about. Think about what types of things I said are conductors and which ones are insulators, and use that to make your prediction. All right, so that washer was a conductor. The next one we will do is a piece of paper. So make your prediction. Do you think a piece of paper is a conductor of electricity, meaning it's going to allow the electricity to flow through it, or is it an insulator and it's going to stop the electricity? Make your prediction. All right, so let's check it out. I'm going to connect my wire to my object. I'm going to touch my object to my metal piece of my load or my output, and the light bulb is not turning on. So that means that this piece of paper is stopping the flow of electricity. Once the electricity gets from the battery through this conductor to the light bulb, it is not able to get from the light bulb back because this is an insulator and it's stopping the electricity. All right, so paper is an electrical insulator. All right, next thing is aluminum foil, like we use for cooking. We wrap our food in it. Okay, make your prediction. Do you think this would be a conductor of electricity or an insulator? Make your guess. All right, let's check it out. I'm going to connect it and touch it. And the light bulb, excuse me, can you see that? The light bulb has turned on. So that means aluminum foil is a conductor. It's allowing the electricity to get back through to the battery and complete that circuit. Aluminum is a type of metal, and metals are conductors of electrical energy. So the aluminum foil is a conductor. All right, next one is a toothpick. Go ahead and make your guess. Is it going to allow the electricity to flow through it, or is it going to stop the electricity? Let me connect it. We'll test it out. Whoops. And the light bulb is not turning on. Toothpicks are made out of wood, and wood is a material that is an electrical insulator. It stops the flow of energy. All right, so far we have two conductors, the washer and the aluminum foil. We have two insulators, the paper and the toothpick. Next, let's do the paper clip. Make your guess. Is it going to allow the energy to flow, or is it going to stop the energy? All right, let's check it out. Let me connect it. Let me touch it, and the light bulb comes on, meaning that the paper clip is a conductor. It's allowing a complete circuit of electrical energy. Good. Also made out of metal. Next, we have a nail, like a real nail that you would hammer into something to build. Go ahead and make your prediction. Is it going to be a conductor or an insulator? Let's check it out. I'm connecting it. Whoops. I'm touching it. And my light bulb is on, meaning that the nail is a conductor. It's allowing the energy to flow through it, creating that complete path of electricity or that complete circuit. Good. All right, we have a couple more objects. The next one is a penny, regular old penny. Go ahead and make your guess. Conductor or insulator. I'm connecting it, I'm touching it, the light bulb is turning on. That means that the penny is a conductor. It's allowing the electricity to flow through. Good job. All right, we have 3 more objects. The next one we're going to do is wax paper, like you bake with. You would put this down on like a pan to, you know, keep your cookies from sticking to the pan, or yeah, to the baking sheet. All right, make your guess. Is it going to be a conductor or an insulator? All right, let's find out. Connecting it, touching it. The light is not turning on, which means wax paper is an insulator. It stops the flow of energy. Electricity cannot go through it. Good. All right, last one is, or no, sorry, 2 more. The next one is a brad. It looks like this. You may have heard it called a paper fastener before. You use this like in, you know, little arts and crafts projects to kind of hold papers together. Go ahead and make your guess. Do you think it's going to be a conductor or an insulator? I'm connecting it, I'm touching it, and the light bulb is turning on, which means the brad is a conductor. It's allowing the electricity to flow through. All right, so we have 1 more object, which is a rubber band. Go ahead and make your guess. Is it going to be a conductor or an insulator? I'm connecting it, I'm touching it, and the light bulb is not turning on because rubber is a material that is an insulator. It stops the flow of electricity. All right, so a couple of things I want you to keep in mind. Number 1 is that electricity can be very dangerous. So just because you are learning about electricity in 4th grade science and electrical energy, that does not make you an expert on electricity. Please do not at home start messing around with batteries and wires and cords and things like that, because you can be very hurt. This is not something to try at home, okay? So please keep that in mind. You are not messing around with electricity. Please remember that conductors are objects that allow electricity to flow through them. Insulators are objects that stop or slow the flow of electricity. Remember, after this video, there will be a short quiz in Schoology for you to take. It's not for a grade, it's not required, it's just extra to see what you know about electricity and conductors and insulators. I hope you had fun, and I'll see you next week when we talk about another form of energy. Bye, guys.